and especially in this video we are going to discuss about the graph of a logarithmic function. Are you ready to watch? So look at the board everybody, and before discussion about the graphs, try to recall the definition of a logarithmic function. See, look at the definition first of all. The function f mapping from r plus nothing but positive real numbers to real number is denoted by y is equals to f of x, which is nothing but log x to the base a, okay, where especially x is any positive number, isn't it? So the positive number I can indicate it as x lies from 0 to in between 0 to infinity, okay, not 0, in between 0 to means 0 point something is nothing but a positive real number. That's what r plus from positive real number, okay. And coming to small a, what about small a, where a is positive real number? We already know that in log x to the base a, log x to the base a, both x and a are positive numbers, and moreover small a should be greater than 1. So that's what here also I mentioned the same thing, where small a is positive real number other than 1, okay, and then log x to the base a is called the logarithmic function, right? Now graph of the logarithmic function is based on the base, that is small a, okay. So here look at the board here, first one and second one, both are the graphs of logarithmic functions only, okay, but depending on the logarithmic base, this decides whether it is increasing or decreasing. See, look at that first one. Here it is nothing but function f of x is nothing but log x to the base a. This is nothing but log x to the base a, and especially here now, if a is greater than 1, if a is greater than 1, then the graph of the logarithmic function is increasing, We understand here? See, from here to as you move on x-axis, y-axis, the point of intersection is nothing but origin, and the graph meets the x-axis at 1, 0. Okay, and you know when a is greater than 1, then this indicates that the graph indicates us that the logarithmic function is increasing, is it not, towards upward direction? So increasing. But you know when you come into this is also the graph of logarithmic function only, log x to the base a. But you know here base a is lies between 0 to 1. If suppose the logarithmic base is lies between 0 to 1, and what can you say about the graph? Is it increasing or decreasing? So simply see from here, no, from the which is close to origin. See, close to origin you are here. When you move away from origin, then the graph is also moving away. I mean, the graph is decreasing. So please remember only 2 lines, my dear. If a is greater than 1, then the graph of log x to the base a is increasing. And if a is lies between 0 to 1, then the graph of the same function, that is log x to the base a, is decreasing. But whenever it is increasing or whenever it is decreasing, you see, my dear, the graph meets the x-axis at the point 1, 0 in both the cases. So please remember once again, if a greater than 1, then the given logarithmic function is increasing, and if a is less than 1, less than 1 in the sense lies between 0 to 1, then clearly the graph is decreasing, and so log x to the base a is less than 0. You know, simply we can say that therefore when a is greater than, then I can say that log x to the base a is greater than 0, increasing. See, finally it lies in the positive coordinates only. Okay, and similarly log x to the base a will be decreasing, less than 0. So please observe these 4 points now, which are very much helpful for us. See, point number 1. For x lies between 0 to 1. See here, x coordinate is here 1, isn't it? Now in between 0 to 1, when x lies between 0 to 1, then the y coordinates are nothing but negative. Is it no? This is below y axis. Negative, no? This is y dash, negative y axis. So do you understand, my dear, here? The x coordinate is here 1. From 1 onwards, the function is raising, increasing. But what about in between 0 to 1? You see, in between 0 to 1, that is when x lies between 0 to 1, then the value of the function is below the y axis. That means y is less than 0. Hence, finally the log x to the base a is less than 0. Y is nothing but what we mentioned, that y is nothing but function. What is the function here? Log x to the base a. So when x lies between 0 to 1, then the functional value is in 4th quadrant. So that means here y coordinate is anyhow negative. So that's what y is negative means. We can say that log x to the base a is less than 0. And to understand you, see, look at this statement now. The curve lies below the x axis. Yes or no? See, the curve, especially in between 0 to 1, the curve lies below the x axis. Do you understand now? Now coming to the point number 2. For x greater than 1. See, when x is greater than 1, this is 1 after maybe 1.1, 1.2, 1.3, 2, 3, 4, 5. Then you look at the curve. It's clearly positive, no? So that's what, when x is greater than 1, then log x to the base a is greater than 0. I mean, the curve lies above the x axis. Isn't it? See, after crossing x coordinate as 1, clearly the graph is above the x axis. Hence, log x to the base a is strictly greater than 0. Positive. Do you understand here? So, when x lies between 0 to 1, when x lies between 0 to 1, hence the function is negative, y is negative, that is log x to the base a is less than 0. That's what we can show it clearly through the graph. In between 0 to 1, the graph lies below the x axis. Below the x axis. And similarly, when x is greater than 1, see, after 1, clearly log x to the base a is greater than 0. Positive. That's what the curve lies above the x axis. And look at the point number 3. If x is less than a, for example, if x is less than a, then we can say that the value of log x to the base a is less than 1. And if x is greater than a, then log x to the base a is greater than 1. So simply based on x is depending on a value, for example. So x is less than a, then log x to the base a is less than 1. And if x is greater than a, then log x to the base a is greater than 1. So next concept is about sign of the logarithmic function. So how can we decide whether the given logarithmic function is positive or negative? This is the concept now what we need to learn. Okay, so to decide this whether the given logarithm is positive or negative, we just need to remember two conditions. So look at the condition number 1. If a greater than 1, x greater than 1, or a lies between 0 to 1 and even x also lies between 0 to 1. So look at once again, my dear, very easy to remember regarding log x to the base a. Now what about x and what about a? If both are greater than 1, a greater than 1, x greater than 1, or both are lies between 0 to 1, Anyhow, they cannot be negative, no? They cannot be negative. Strictly they are positive. So the thing is either 0 to 1 or more than 1. That is the only condition. So if both are more than 1 or both are lies between 0 to 1, then simply we can say that log x to the base a is greater than 0. Greater than 0. That is positive. Isn't it? Hence the given logarithm is a positive. If not, look at here. Suppose a is lies between 0 to 1 and x is greater than 1. I mean 1 is less than 1 and 1 is greater than 1. Or a greater than 1 or x lies between 0 to 1. So easily we can remember that within this a and x, case 1, a less than 1, x greater than 1. Case 2, a greater than 1, x less than 1. So one value is lies between 0 to 1 and one value is greater than 1, then simply we can say that the given logarithm, that is log x to the base a, is less than 0. I mean the given logarithm is negative. Do you understand, man? Very easy to remember. If both are same category, I mean both are greater than 1 or both are lies between 0 to 1, then it is clearly positive. If one is greater than 1 and if other one is 0 to 1, lies between 0 to 1, then the logarithm is negative. Okay. Now let us discuss one question based on this. Determine the sign of log 4 by 5 to the base 0.1. Okay. So first, compare the given logarithm with log x to the base a. Here log x to the base a is nothing but log 4 by 5 to the base 0.1. I mean x is nothing but 4 by 5 and small a is nothing but 0.1. Right? So x 4 by 5 means 0 point something. 0 point something means I can say that x is lies between 0 to 1, right now. Even a is also 0 point something, I mean 0.1. I mean a is also lies between 0 to 1. So x and a both are lies between 0 to 1. Hence this is the condition. Now can you decide the sign of the given logarithm? So clearly it is positive. Therefore, I can say that log 4 by 5 to the base 0.4 is positive. The sign is positive. I mean greater than 0. Right? So look at the one more question, that is determine the sign of log of pi by 4 to the base 10. Log of pi by 4 to the base 10. So just compare the given logarithm with log x to the base a. And can you say what is x is pi by 4 and a is nothing but 3. So you know x is pi by 4. Pi value here you can take it to 22 by 7. I mean 3 point something. So 3 point something by, for example, if I take 3.14 by 4, clearly which is less than 0. Which is less than 0. But you know here a is equals to 3, which is greater than 1. I mean here x is less than 0. Sorry, 0 point something, no? Less than 1 we can say. 0 point something, less than 1. I mean x is lies between 0 to 1. Whereas a is greater than 1. So both are opposite. One is more than 1, one is less than 1. Then what is the sign? Clearly it is negative. So answer log pi by 4 to the base 3 is less than 0. Okay, now let us try one more question. So coming to the next question, determine the sign of log of 3.162 to the base a by log of 2 by 3 to the base a. Okay, so my dear, how can we write this is log a and log a, bases are getting cancelled. This is also I can write log a by b, and this is also we can write it as log a by b. So furtherly, can I write this as 3.162, log 3.162 by log of 2 by 3. Okay, and this is, we can also write it as log of 3.162 to the base 2 by 3. Now this you can compare with log x to the base a. Log x to the base a. So here, what is x? X is nothing but 3.162. Clearly, x is greater than 1. Okay. And coming to the value of small a is 2 by 3. So that means 0 point something, anyhow a is less than 1. So what are the conditions we got it here? X is greater than 1. A is less than 1 in the sense lies between 0 to 1. So 1 is more than 1 and 1 is less than 1. So then 1 is more than 1 and 1 is less than 1. And what I can say that? So therefore, log of 3.162 to the base a by log of 2 by 3 to the base a is less than 0. Negative. Okay, do you understand how to find the sign of a given logarithm? So look at one more question in this model. So determine the sign of log 3 by 2 to the base 1 by 3 and into log 5 by 3 to the base 2 into log 7 to the base 1 by 2. Finally everything into. So we need to discuss about the sign of the given logarithm. Okay, so now first of all take individually their signs. Log 3 by 2 and 1 by 2. That means 3 by 2, clearly x is greater than 1 and 1 by 3. So a is less than 1. Isn't it? And what can we say? Therefore log 3 by 2 to the base 1 by 3 is negative, isn't it? Less than 0. Now go for log of 5 by 3 to the base 2. So that implies x is equals to 5 by 3, 1 point something, hence greater than 1. And clearly small a is 2, which is also greater than 1. Hence the condition is x greater than 1 and a is also greater than 1. What can you say? That implies log 5 by 3 to the base 2 is positive. Isn't it? Both are greater than 1. Case 1 is clearly greater than 0. Now coming to the third one, see also what we have here, log 7 to the base 1 by 2. So that implies What is x is 7, I mean greater than 1, and a is 1 by 2, 0 point something, means lies between 0 to 1. So 1 is greater than 1 and 1 is lies between 0 to 1. Answer, what can we say that? Log 7 to the base 1 by 2 is again less than 0, negative, isn't it? Now we want the product of this everything. No? If you consider this as some condition number 1, now 1 implies, you look at their signs. No? First one sign is negative, second one sign is positive, I mean minus into plus, and this is again minus. So minus into plus minus, minus into minus plus, which is equals to positive, which is equals to positive. So therefore enter log 3 by 2 to the base 1 by 3 into log 5 by 3 to the base 2 into log 7 to the base 1 by 2 is greater than 0. Positive, no? So in this way we can discuss about the sign of the given logarithm. Just you need to remember those 2 points. So next concept is about how to decide which of the following logarithm is greater than the other one. Okay, so look at this statement everybody. If a lies between 0 to 1 and x1 is less than x2, then log x1 to the base a is greater than log x2 to the base a. So using this concept we can decide which is greater than. So coming to question number 1. So we need to check that log 7 to the base 1 by 2 or log 11 to the base 1 by 2. So among these two, which is greater? Okay. Now look at me here. What is the value of a? Just you need to compare with log x to the base a. So luckily here we have both bases are same. So here small a is equals to 1 by 2. That means, can I say that a is lies between 0 to 1? Isn't it? And also, if you compare this as x1 and this as x2, so clearly 7 is less than 11. I mean x1 is less than x2 according to that concept. Then what it is? If a is lies between 0 to 1 and x1 is less than x2, hence what I can say that therefore log x1 to the base a is greater than log x2 to the base a, right? So according to that, what is log x1 to the base a is nothing but x1 is 7. So log 7 to the half, base half is greater than log 11 to the base 1 by 2. Do you understand now? Now clearly log 7 to the base 1 by 2 is greater than log 11 to the base 1 by 2. Okay. But most of the students, they may think, since the bases are same and coming to the numbers than 7, 11 may be the greater than 1. So they may think that this part is greater than the first part. But it is not like that. So it's not depending on numerical values. So this is clearly based on the logarithmic base. So coming to the next problem, log of 0.5 to the base 2 or log of 0.7 to the base 2. So within these two now we need to decide which is greater. Okay. So look at the second point now. If a is greater than 1, earlier one is a is lies between 0 to 1. If suppose a is greater than 1 and x1 is less than x2, then log of x1 to the base a is less than log x2 to the base a. Okay. So see here, a is nothing but 2, which is greater than 1. Okay. And clearly 0.5 is less than 0.7, i.e. that is x1 is less than x2. Then according to second point, what can I say? That log x1 to the base a is less than log x2 to the base a. That means x1 log of 0.5 to the base 2 is less than log of 0.7 to the base 2. So clearly which is the greater one here? The greater one is nothing but log of 0.7 to the base 2. So when you want to discuss about which is greater than or which is lower than, then please concentrate on the base. If base is lies between 0 to 1, then use this identity. And if a is greater than 1, then you can use the second identity. So coming to third problem, log 11 to the base 2 or log 2 to the base 11. Now bases are different here, isn't it? So earlier what we discussed the two models, bases are same, but here base of the first logarithm is 2 and base of the second logarithm is 11. So different bases. Then also no problem, we already discussed in the beginning of this class. Well, in the beginning of this class, that is, if x is greater than a, then log x to the base a is greater than 1. Isn't it? X is greater than a, then log x to the base a is greater than 1. Also, if x is less than a, then log x to the base a is less than 1. So these are the two more points we discussed in the same class now, in the beginning while we are discussing about the graphs. Okay, now clearly look at the first logarithm, log 11 to the base 2 can compare with log x to the base a. So that implies see clearly x is greater than a, 11 is greater than 2. So I can say that x is greater than a. If x is greater than a, that implies log 11 to the base 2 is greater than 1. This is clearly greater than 1. So look at the second condition, what is given? Log 2 to the base 11. So this is now you can equate it to log x to the base a. Now clearly 2 is less than 11. That means I can say that x is less than a. Right? So when x is less than a, what about its logarithm? Log x to the base a is less than 1. Hence log 2 to the base 11 is less than 1. So clearly this is more than 1 and this is less than 1. Therefore, what we can say now? Log 11 to the base 2 is greater than log 2 to the base 11. Am I right? So be careful with the logarithmic inequalities to discuss about the sign of the logarithmic function as well as when you want to compare the two logarithmic functions, I mean which is smaller and which is greater. So as I told you, you better to revise the once again, especially laws of logarithms and moreover logarithmic inequalities. If you are good at these two, so that you can solve the subjective task problems too. Is it clear to you all? Okay. So hope you all understood the concepts what we discussed in this one, especially in this class. Okay, so please revise. My sincere advice to revise the logarithmic inequalities once again, and then you can start practice the subjective problem set 2. Right? Thank you everybody. Thank you for watching this video.